Hello, welcome to Vega Achiever Educational Limited, presenting Rio Tutor, trusted for being friendly and high impact learning. Today, we'll continue from our previous class, Paper 1, AQA, GCSE Chemistry Overview. Now, in our previous class, we discussed about the reactivity series, which then is going to lead us to talk about the displacement reaction and extraction. Now, what is displacement reaction? Displacement reaction, this involves when a more reactive metal can displace a less reactive metal from its compound. For example, zinc displacing copper from copper sulfate to form zinc sulfate and copper. In this case, zinc is more reactive than copper and zinc displaces copper from its solution. Here is a reactivity series that shows how metals are arranged based on reactivity from the most reactive to the least reactive. Now you can see that in that list, zinc is above copper in the series. So hence, zinc will displace copper according to that reaction. Let's take a look at the reaction again. Okay, you can see this is an image showing the reaction between zinc and copper sulfate. Zinc will displace copper sulfate from the solution, forming zinc sulfate and displacing copper. In the reactant side, which involves zinc and copper sulfate, which is CuSO4, and in the product side, it involves zinc sulfate and copper, which is ZnSO4 plus copper, which is being displaced. Now, what happened during that reaction with zinc and copper sulfate? If you notice, zinc is more reactive than copper, and zinc pushes copper out of the copper sulfate. The copper metal forms as a brown solid, and blue solution fades. In conclusion, you can say zinc displaces copper. So that's what happened in that equation. Now here is another example of magnesium displacing iron from iron sulfate. Now magnesium is more reactive than iron according to the reactivity series, so it will also displace iron from iron sulfate. That's magnesium will definitely displace iron. Example of non-reaction, for instance, now copper cannot displace iron from iron sulfate because copper is below iron in the reactivity series. I haven't discussed about that, so our next line is why displacement happens. Now let's know the reason why displacement reaction occurs. Now, one thing you need to know about displacement reaction is that the reason why it happens is because one, more reactive metals loses electron more easily. Two, less reactive metals hold the electron tightly. And lastly, the more reactive metal form ions and push out the less reactive metal. So in that way, displacement happens. So take note of it. This next in line is extraction of metal. Now, what is extraction of metal? Extraction of metal is the process of removing a metal from its ore. Now, the method used depends on the metal's position in the reactivity series. Now, you can see that all of this always boils down to the reactivity series, which means if you understand the reactivity series, you will know these things easily. Yes, you will know them easily. Now, so let's go to the next slide. Here you have the key ideas of the things you need to know. Number one on this list is for you to understand the word very unreactive metals. Now, very unreactive metals are found native, that's pure, in pure state. Metals that are unreactive are found native or are referred to as native metals. Okay, good. Now, two, metal below carbons are extracted by reduction with carbons. Yes, metal below carbon in the series are extracted by reduction with carbon. And three, metals above carbon are extracted by electrolysis. What this is trying to say is that for the first key word you need to know is that metals that are unreactive are not extracted, meaning they can be found naturally. Secondly, metals below carbon are extracted by reduction with carbon, while metals above carbon in the series are extracted by electrolysis. Now let's take a look at the series one more time so we can understand that perfectly well. Here's the table showing the reactivity series one more time. You can see that meaning zinc, the likes of zinc, iron can be extracted by reduction, while the likes of aluminium, magnesium, calcium, sodium can be extracted by electrolysis, while those that are unreactive, like silver, gold, platinum are found naturally. That is how we can call them native metals. I haven't talked about that. Let's talk about metals found native. You can see them example right here is gold, silver, and platinum. Now these metals are found uncombined in the earth because they do not react easily. Yeah, they are unreactive. Now, so let's move to the extraction processes. The first of all this is going to be extraction using carbon. That's by a process of reduction. Now, metal less reactive than carbon are extracted by heating their ores with carbon, and such metal include iron, zinc, and copper. Now, if you're asked on exam, which of the following can be extracted by reduction, just have the mindset is either iron, zinc, or copper. Any of them can be extracted by what reduction? Yes, because they are below carbon now in the series. So let's go to the next, extraction by electrolysis. Now, if you notice, metals that are more reactive than carbon must be extracted using electrolysis method. Now, and these metals are potassium, sodium, calcium, magnesium, aluminium. All of these metals are extracted by electrolysis. Now, why electrolysis? This is because these metals are too reactive to be reduced by carbon. And in this case of electrolysis, electricity is used to break down the molten compound, before it can be extracted. I will talk about that now. Let's talk about some GCSE question. Let's attempt some of them. Before we attempt those GCSE questions, let's take a look at this. For instance, extraction of iron. So remember, iron is below carbon in the reactivity series, hence iron will be extracted by reduction. If you should observe the equation very well, iron oxide is being reduced to iron and carbon dioxide is being produced, which simply means the carbon monoxide removes the oxygen from the iron oxide, leading to the production of iron. Hence, iron can then be extracted and collected that way. So there are a lot of series of process involving this, but this is the basics you need to know how it happens. Reducing iron oxide to produce iron and carbon dioxide. Now, I haven't talked about that, so let's look at the same for the extraction of aluminum oxide by electrolysis, which is above carbon in the reactivity series. In this aspect, aluminum oxide is melted and the current is passed through it, and at the cathode during electrolysis, aluminum is produced, and then from there aluminum metal is formed and also is extracted from that process. So I haven't said all of this now, so let's attempt some typical GCSE question, be it foundation or higher. Now let's start. Question on our list is iron is found in the earth as iron oxide. Iron oxide is reduced to produce iron. Balance the equation for the reaction. Now, to balance this equation is very easy. You have to add the back of Fe2O3. Then after adding 2 there, then in the case of carbon, you just add 3. And at the product side, the iron, you had 4 at the back of iron. And at the carbon, 2 in the carbon dioxide, then you had 3 at the back. That way you balance the equation. As for the question H, they said name the elements used to reduce iron oxide. Way too easy. This is from extraction anyways. It's carbon, since they said name the elements, not compound, so it is carbon. And as for the last question there, they said what is meant by reduction. Just know that reduction is simply the gain of an electron, and the opposite of reduction is oxidation, which is the loss of electron. Okay, we are done with this question, so let's go to the next question. The next question says steel are used to make cars, bridge, knives. The main element in steel is iron. That's true. Iron is extracted from an ore that contains about 60% iron oxide. What is the meaning of ore? An ore is a rock that contains enough metal that make it worth extracting. That is it for Roman figure I. Roman figure II. The question says, in a blast furnace, iron oxide reacts with carbon monoxide to produce iron. The word equation for this reaction is, okay, a blast furnace is the furnace used in the extracting of iron from iron oxide. Now, they said this is the word equation, iron oxide plus carbon monoxide to produce iron plus carbon dioxide. They said complete and balance the chemical equation for this reaction. Now, remember, this was explained before we actually started answering our GCSE question, and here is the answer to Roman figure II. I've also said that. Now let's move to Roman figure III. Roman figure 3 says, name the type of reaction that produce a metal from its metal oxide without being told. Metal below carbon are extracted from their oxide by reduction. So it's redox reaction or reduction reaction. So I will talk about that. Let's move to the next question, which we have here on the list F. And this particular question says, which metal is found in the earth as a metal itself? The answer is way too easy. This is talking about native metals or pure metals, which is actually gold. If gold was not to be there, platinum would have been the answer, or silver. So thank you very much for your time. God bless you. See you in my next class.